Right, so today we're going to talk about SVG animations. And I guess we should start with why even animate? Why would we want to add animations to our application? So there are a couple of reasons why we might want to do this. The first is that we can use animations to convey information. So for instance, we've all seen a loading spinner. The fact that it's moving is what tells us that the page is loading. I mean, even if it's a lie, it still gives the impression of the page is loading. And for whatever reason, we've decided that when AI is loading, then we should indicate that with a rainbow border that also animates. Not going to lie, I think that's the best thing about AI. We can use animations to convey other information though. So for instance, if we have a user who tries to submit a form and there's a problem with it, we could convey that with a little shake on the button. Yeah, so there's a bunch of different things we can convey through animations. We can also use animations to give our UI a more kind of polished feel. So for instance, if something just appears out of nowhere, we can find that quite jarring. Whereas if we make our modals all sort of fly in from the left or from the top, that feels a lot nicer for most people. We can also use animations to smooth out interactions on our site. For instance, here when we have this hover state, when we move between the different navigations, then the hover state sort of moves smoothly, which is a lot nicer, I think, than just having it appear and disappear. So we can add a bit of polish to our UI. We can also use animations just to add, I don't know, a bit of fun, a little bit of pop, make our apps a bit more engaging. So for instance, we have three SVGs, 3 images here, which we use in our app. We have a form where a user needs to choose a type of chart. And so we have some custom radio buttons, and the radio buttons have these little icons on them, and the icons are animated. So the first one here, the numbers jump up and fall down. The second one, the bars animate in, and the third one, the line graph draws itself. So these are the animations that we're going to have a look at today. We're going to run through how to create them. They are all just pure SVG and CSS. We don't need any JavaScript at all. So let's have a look at how to do that. Before we get started though, we need to have a quick chat about why we would use SVG rather than some other image format for this. So it turns out that SVG is not like the other image formats. So most image formats are basically just a bitmap with some kind of compression algorithm over the top. But so as an example, we have here this little heart icon. We can turn that into a bitmap, which basically represents each pixel in the image is represented by a letter that is the color of that pixel. So W for white, B for black, and so on. And then we can run a compression algorithm over the top to make it smaller to send to the user. I came up with this compression algorithm myself, so you're free to use it if you like. I wouldn't recommend it though. And the important thing is that in a traditional image format, what the file is representing is the color of each pixel in the image. When it comes to SVGs though, that's not what we're representing at all. In an SVG, what we're representing are the vectors in the image. So vector is the V in SVG. And for purposes of this, a vector is just a line. So our heart icon here has a single line, the light blue line around the outside, and it's represented by the path element inside our SVG here. The way that it works is this D property is saying M47 means move to position 47, which is the bottom of the heart here. L is line, draw a line to position 14, which is the top, the mid left, I guess, of this part here. A is draw an arc, so we're going to draw an arc to point 42, which is the middle of the top here, and then another arc to 74, which is over on the right hand side here, and then finally Z just means go back to the start. Right, so you can see that nothing here is saying what color any particular pixel should be. We're just saying, hey, draw this line. We are saying what color the line should be, but we're not saying what anything at any particular point on the file should be. So why do we care about that? Why is that useful? Well, the first is that it means that our images are scalable. So scalable is the S in SVG. The G is graphics. If you were wondering, I'm not going to go into that any further. But here we have, this is a PNG image. don't read the alt text because it's lies. It is actually a PNG. And if we set the width to like 1200 pixels, you can see it starts to get blurry, it gets a bit pixelated. It doesn't really look good. Whereas if we do the same thing on our SVG here, it still looks great. It still looks perfect. Everything is still crisp and clean. There's no blurring. It just scales really well. There are some trade-offs here. So all of these like highlighting and shadow and gradients and semi-transparency effects that we've got going on with the PNG, these are quite difficult to do in an SVG. SVGs are much better suited to things with like simple colors and like flat looking shapes, which is handy because that's sort of what's popular these days. But it does mean that if you did for some reason want like a really big version of this heart on the left here, I would recommend that rather than trying to do it as an SVG, you probably just want to create a PNG that is a higher resolution. Good luck with that though, because that's an image from a video game from the 90s, and that was the highest resolution it comes in. Anyway, the scalable isn't really what we're interested in today because like our icons aren't that big. Being able to make them huge isn't really that useful. The thing about SVGs that is more interesting for today is the way that you can use them. So you can use SVGs just the same way that you use any other image. For instance, you can pass them as a source attribute on an image element or pass them into CSS. So anything you can do with a PNG or a JPEG or a WebP, you can also do with an SVG, which is fine. But the more interesting thing is that because SVGs are HTML-ish, you can actually just use them directly in your HTML. You don't need to create an image and import it. You can just put the actual SVG elements directly into your HTML. Now this used to be a little bit tricky because it meant that if we wanted the same heart icon to appear like 40 times in our application, we'd have to send that HTML 40 times to the user. And we didn't want to do that, right? We didn't want to send all those extra bytes for no reason. Luckily, at some point we just stopped caring about that, and now we just send megabytes. Now we have components. So we can just create a component using whatever component library you like and just have it return the SVG, and then you can reuse that throughout in your application just like any other component. Which I guess is cool, but why would we want to do that? Well, the reason we want to do that is that if we start using SVG as HTML, then that means that we can also use CSS with it. So if we have a look again at our heart here, we've got this path. We can add some CSS to it. We can use the #1 best CSS debugging tool, which is Outline. We can make it dashed and lime. We can't see it very well, and that's because SVGs have overflow of hidden by default. So we can just make that visible. And then you can see we have our outline applied. It is weirdly huge, but we will get into that, why that is a bit later. Okay, so I guess we've proved the point you can apply CSS through SVG elements. There are some limitations though. So there's some things that just aren't going to work at all. If I set the width on this element, it's not going to have any effect because the width of a path is determined by the values of this this D property. So you can't change the width, like min width, max width, any of the width properties or like any of the height properties. They're just not going to work. There's also some stuff that works a bit differently in SVG. So for instance, if I try to set the color or the background, those aren't going to have any effect, right? Nothing's going to change there. And the reason for that is that SVGs don't use the color and background properties to affect the color and background. Instead, it has its own SVG specific things. So instead of using color here, we can use stroke. And instead of using background here, we can use fill. You can also pass SVG variables into this. So we could pass in like a custom property, or we could pass in a true CSS variable like current color. I don't know if you can see the difference there, but that's now white. So this is super handy if you're using SVGs as icons and you want the color of the icon to match the color of the surrounding text. You can just set the stroke and fill to current color, and then it will automatically change according to the color of the surrounding text. Okay, so that's pretty cool. Can we use that now to complete our first little example here? So what we want to happen is we want these numbers to jump up one at a time, and then when we hover, and then when we unhover, we want them all to fall down like at the same time. So if we jump in here, our SVG here, you can see that it has 3 path elements. One is the number 1, which is blue. The second one is the green, number 2, and the third one is the pink, number 3. So we want to target those so that they move up when we hover over the SVG. So CSS selectors work the same with SVG as they do with any other HTML. So if we create a new selector here, this SVG has an ID of numbers. We can create a CSS selector, which uses numbers, and then we can use the hover pseudo class, and then we can select all of the paths inside the numbers element when it's hovered. And to get them into that upwards position, we can use a transform. And we can just say translate y, and we can make it -10%. All right, so now if we hover over this element, it's going to jump up. It's not quite what we want though, to this sort of jerky thing going on. So the next thing we want to do is to smooth out that motion. And to do that, we can use CSS transitions. This time we don't want the transition only applied on hover, because we want it to apply both when we hover and when we don't hover. So we need to create a new rule. It's just going to be numbers and the path, and we can say transition, transform, and like 0.2 seconds. All right, so now it moves up and down smoothly, but we don't have that effect where the numbers move one at a time. So to do that, we need another couple of rules. So we want these to move on hover, not on unhover. So we want another one that is numbers on hover. And then we need to select each path element individually. We don't need to do anything with the 1, we can just skip that. But then we can say nth child 2 to select the second path, and we can give it a transition delay of, so the time, like the transition duration is 0.2 seconds. So the number 1 is going to move up after, like, it's going to be finished moving at 0.2 seconds. So let's make this a little bit less than that, 0.18 seconds. And then we need another one for the 3. So we can say numbers on hover. Let's just go nth child 3, because they're all paths. We don't really need that selector. And we can say transition delay. This time we want it to be double what the 2 was, so 0.36 seconds. And that's it. We're done. All right, cool. So what have we learned so far? SVGs are HTML-ish. You can use CSS with them. We know that there's some limitations to that, but you can absolutely use CSS transforms and also CSS transitions. All right, on to our next example. So this one is a little bit different to the previous one, because with the numbers, we had a start date, and then when we hovered, we animated to an end state. But with this one, the start state and the end state are the same. So we can't just like animate from one to the other. We need to do something a bit trickier. So this is what it needs to look like. Before we hover, it looks like this. As soon as we hover, it moves to this state. And then once we finish the animation, it's going to be back at the start date. We can achieve this middle state here using another CSS transform. This time we're going to use scale y 0, which is just going to give each of the elements a height of 0, essentially. Then to achieve this animation, because we can't do it with a transition, we need to do it with a keyframe animation. So we want this to work so that when we hover over the SVG, the animation gets applied, and then it's immediately going to move to this scale 0 condition, and then over the animation duration, it's going to animate to this back to the scale 100%, scale y 100% condition. All right, so back to the start. All right, so let's do that. Now, this SVG has 4 paths in it. We've got 3 that are the green bars there, and then the 4th one is the gray axis around the outside. we don't want to animate those axes, right? So we need a selector that's going to select the bars, but not the axes. So we're going to go on hover again. These bars all do have a class on them of just bar, so we could just choose that. If for some reason though you have an SVG where you don't have a class on it like this and you can't add one for some reason, you can also just use other SVG selectors. So for this one, for instance, I might say I want to select all of the paths that don't have an attribute of stroke equals gray. And that's going to select everything that's not this stroke equals gray. So everything except for the axes. You could also have done it that I want to select everything that is green, but this way you could have the bars all be different colors. Yeah, whatever. Do what you like. Okay, so now we've got our selector, we can apply our animation, which is going to be animation, it's named squish, and we can have it run for like 2 seconds. Okay, so that's not right. So obviously it's animating from the top instead of the bottom because that's just how animations transforms default. To change that, we can just jump in, and this time let's just take the easy way and use the bar class. And we can say that instead of our transform origin being at the top, we want it at the bottom. Okay, so that's better. But if you look closely, you'll notice that our bars are actually animating in from below the x-axis there, which is not exactly what we want. And the reason for that is that, for some reason, by default, when you have an element inside an SVG, the box that's used to calculate the transform origin, so the box that you're animating from the bottom of, isn't the element, it's the view box, and the view box is like the entire SVG. So maybe use another outline here, maybe 4 pixels. You can see that where those bars are animating in from is actually the edge of the SVG. Luckily, there is an easy way to fix this. There's a property called transform box, which controls, unsurprisingly, the transform box. So by default, it's going to be view box, but we can set it to fill box. And now you can see that the SVG animates incorrectly. Whew. Okay, so what do we know now? SVGs are HTML-ish, we can use CSS. There are limitations to the CSS, but we can use transforms and transitions and also animations, but we do need to be a bit careful with that transform box. All right, so that brings us to our final example, which is this line graph that draws itself. I love this effect on SVGs, the way that they just draw themselves. It's my second favorite thing that you can do with SVGs. I think it's very cool. But before we do that, we need to understand a couple more things about SVGs. So the first is how the viewbox and SVG units work. If we have a look at this SVG here, you can see it's got this attribute viewbox. Most SVGs, basically any SVG that you see, is going to have this attribute viewbox. It's not required, but it does make things a lot easier. So there's almost certainly going to be a viewbox attribute on your SVG, and it's always going to have 4 numbers. The first 2 numbers are the X and Y offset. Don't worry about them. They're just always 0. It's fine. They're just 0. Forget about them. The second 2 numbers are the width and height, but they're not like the physical width and height of the SVG. So for instance, this SVG has a width of 600 pixels, not 1000 pixels like you might think, because the CSS overrides the one on the SVG. It's a whole thing. Anyway, this width and height are not the width and height of the SVG physically. They're the width and height of like the coordinate system that we use inside SVG. So when we say that this SVG is 10 by 10, basically what we're saying is that this SVG is a grid that's 10 wide by 10 high, and that's what we're drawing everything relative to. So this path here, we're going to start at 0.11. So you can see this is 1, 1 on this grid. We're starting here, and then we're going to draw to 0.99. So down here, you can trust me, this is 9 across and 9 down. The stroke is overlapping the different squares a bit because it also has a width of 1. So the width of this line is the same as the width of one of these boxes. So when you turn it sideways, it's going to stick out. All right, so everything is just relative to this 10 by 10 grid. And in fact, if we make this SVG like bigger or smaller, it's not going to matter. Everything is still just relative to that grid. And if we change the grid, so we could make this instead 20 by 20, then you can see that everything is now relative to this new grid. So our path still starts at 1, 1, but 1, 1 is much closer to the edge now. And it still goes to 9, 9, but 9, 9 is now only halfway through the path. Right? So everything is just relative to this grid, which means that nothing has units on it, right? You're not saying something's in pixels or anything, you're just saying it's 1, or it's 9, or it's 7, or whatever. And it's just going to be relative to whatever the view box value is here. So that's why when we had our, actually, let's make this back to 10 and 10 again, not 210. So that's why when we add like our outline, actually the outline is a bit of a special case because when you're specifying an outline, you do need to put a value on it, a unit on it. So you can't just say 1 dash line. That's not going to make an outline. You'd need to put 1 pixel. But that 1 pixel is going to get converted to 1 in the SVG unit system. Again, you can't see this because this. But yeah, so this is going to get converted to 1 in the SVG unit system, which means that this dash is going to be the same width as this stroke, right? It's going to be massive. So that's what's going on with that. Okay, so viewbox and everything is unitless. We've got that. Then the other thing we need to understand is the parts of a vector. So a vector or a path in SVG has 2 parts. It has a stroke and a fill. So the fill is going to be anytime you draw a line that encloses some part of space, then that part of space will get filled in. So for instance, with our heart earlier, the path enclosed that heart shape, so the middle was all filled in red. This is very obvious and intuitive when you have a line like a closed path, where the start and the end are the same. Like our heart, it's a little bit less intuitive with something like this, where you've got an open path where the start and the end aren't at the same point. But what's going on here is basically just that it's, that's not the right SVG. What's going on here is that you can just imagine what would happen if you did draw that line back to the start. Then those are the parts that would be enclosed, and that's what's going to be filled by the fill. We're not that interested in fill for our purposes today, so we can just set that to none, and we won't see it. The thing that we are interested in today is the stroke, which is the actual line that you're drawing. There are a bunch of things that you can affect about the stroke using SVG. So for instance, we can change the color, and that's just the proper stroke itself. Make it green. We can change the width. So again, we use these unitless values, and it will just make it relative to the view box, which in this case is 56 by 56, because you don't have to have boring numbers. Let's make that 2. You can also like change the way that the lines look. So for instance, we could make line cap round and line join round, and then we get like this friendly version of the same line. Isn't it nicer? This is going to interfere with what I want to do next though, so I'm just going to get rid of that. The thing that we care about for our purposes today though is that we can also make this line dashed. So we can say stroke dash array is 4, and now our line is going to be made of dashes, where each dash is 4 long, followed by a gap of 4. If you're wondering why this is dash array and not just when it's just a number, it's because you can add more numbers. So I could put 1, and now I get a dash array that is a dash of 4 followed by a gap of 1. But I keep adding numbers. So I could have a dash of 4 followed by a gap of 1 followed by a dash of 7 followed by a gap of 4, and so on and so forth. You could, I don't know, write a Morse code message with it or whatever. For today though, we just need 1 value. And the final piece that we need is that we can change how, like where the dashes are drawn from. So we can say stroke dash offset is 2, and you can see that this first dash here it sort of starts to before the edge of the path. So it's shorter. For our purpose today, the exciting thing about this is that you can animate the stroke dash offset. So if we set a transform of stroke dash offset and like 1 second, not transform, transition, stroke dash offset at 1 second, and then we change this dash offset, you can see the line moves. So now if you imagine what would happen if we made it so that the dash array was like the same length as the line, so that one dash was the entire path, and then you made the dash offset the same length, so now the entire like dash is off screen and you can't see it, and then you animate dash offset to 0, so then the dash that's off screen gradually comes on screen, the SVG draws itself. All right, so to make that work, the first thing we need to know the length of the line. And there's a couple of ways that we could work this out, I guess. The first is that we could look at this path and we could grab all of these numbers and we could trigonometry the shit out of them and figure out how long the line is. We're going to not do that today. The second thing that we could do is we could guess. So we know that this view box is 56 by 56. This line is like, I don't know, 1.5 times the width. So we could guess that the dash length is like 75. And then we could just play with numbers. So that's too long. 72 is a bit short. It's somewhere between 72 and 73. For the purposes of this, that's probably close enough. We could just use 72 or 73 as the value and move on with our lives. However, there is actually a way to get the exact value here. It's just that we have to do some JavaScript. And I promise that we don't have to do any JavaScript. I think you'll be okay with this JavaScript though, because it doesn't need to run at runtime. It doesn't even need to run at build time. We're just going to run it once and get the length of the line. And then because SVGs like use this unitless relative sort of situation, we can just keep that number and it's going to stay the same no matter what size the SVG is actually displayed at, right? We just need to get the number once and we can put it in our CSS. Nobody will even know that we ran any JavaScript. Okay, so to do that, we need to run a function called getTotalLength. This is just a property that exists on all SVG path elements, possibly other SVG elements, I'm not sure. And we can see that the length here is 72. All right, so if we jump back in, let's just grab a fresh copy of our SVG here. And we can use this value. So the first thing is that we want the dash array and the dash offset to be the same length. So rather than repeating the number, let's just create a variable or a custom property. All right, so we've got that there. And then we can set the stroke dash array to be that length. You can see I'm setting these actually on the SVG rather than the path element. Everything on the SVG will be inherited by the path, so either one works fine. Okay, and then to make the line actually animate, this is the same as our bar chart example where we have the start state and the end state are the same, and we need like a third state in the middle. So we need to use a keyframe animation, which is going to look like this. We're going to start, as soon as the animation starts, we're going to move to this initial condition where the stroke dash offset is the same as the length of the line. And then we're going to animate to this finishing condition where the stroke dash offset is 0. Okay, so we can just add that animation and say on our SVG, on hover, we want the path to have an animation. It's called draw line, and we want it to run for, I don't know, like 1 second. All right, so now when we hover the SVG, it draws itself. Isn't that cool? Ah, I love that. I think it looks a bit better if you make it like a linear. But yeah, anyway, so that's how you do that. Isn't it cool? All right, so what have we learned? SVG is HTML-ish. We can use CSS. We can use CSS transforms, transitions, and animations. We need to be a bit careful with transform box. And also, we can animate SVG-specific properties, which is super cool. All right, so hopefully you will take this and go out and add some animations to your application. But before you do that, there are a couple of things that you need to keep in mind when using this great power. The first thing actually isn't even related to animations. It's about hover. and that is not everyone uses a mouse. So for the purposes of demonstration today, I had everything trigger on hover just because it was easy, but that's not going to work for keyboard users, for screen reader users, or for people on touchscreens, and that's not great. So what you actually need to do to make your particular application work for everyone is going to depend on exactly what you're using the animation for, but a solid first base, a solid starting point is that anywhere where you have a hover pseudo class, you should also add a focus pseudo class. For this particular application, that's enough because it'll now work for keyboards and mouses. And I think it'll also work for touchscreens because they'll get focus when you tap the radio button. Maybe it'll only work for the first one. But it's okay in this case because our animations are purely decorative. So if they're not there, if screen reader users can't use them, that's okay. It's not really adding anything to their experience anyway. If your animation, though, is doing something critical in your application or conveying information, then you need to make sure that that information is conveyed by some other means as well. So for instance, if you're animating a loading icon, then that's great. It'll work great for keyboard, mouse, and touchscreen users, but it's not going to work for screen reader users. You need to also have some text somewhere that says that the page is loading. And that text can be hidden so that only the screen reader reads it out and sighted users don't see it, but it needs to be there somewhere. Okay, the second thing is that movement can cause motion sickness. So if you have large animations that are causing a lot of movement in your app, then that can make people sick. This one, luckily, is easy enough to sort out. You can just add a media query to animation that says if the user prefers reduced motion reduce, then you can reduce the motion. It's worth noting that you don't need to apply this for animations that don't involve motion or animations that only apply small amounts of motion. There's also an exemption if you need the motion for your application to function, then you don't have to do this, but you might want to think about whether you're making users sick. The other thing is that you don't need to get rid of the animation entirely. I have here, just because it fit on the slide easily, you can just change the animation so it's a smaller motion or something that's not motion. I'll show you an example of that in a tick. The other thing is, how do you test this, I guess? It's a little bit tricky because it is actually an operating system setting. So in Mac, you need to go in to the accessibility settings, you need to go to display, and then there's this reduce motion setting. The other option is if you're using Firefox, you can go into the advanced preferences, and there's this prefers reduced motion. 0 is off. It's not Boolean, it's 0 and 1. But if it's off, then you can see, for instance, I don't need to save it. For instance, this is the MDN prefers reduced motion page. It has this box here that's pulsating in a mildly disturbing manner. But if we switch this to 1, then they switch the animation to just a change in color or opacity or something there. And so that's the kind of thing you can do. Finally, the third thing that you need to keep in mind is that flashing can cause seizures. So anybody who lived through the 90s and remembers the whole Pokemon scenario, you'll be aware of this. But yeah, if you have too much flashing going on in your application, it can cause people to have an epileptic seizure. WCAG has a bunch of guidelines related to this. There's a lot of words that basically says things shouldn't flash more than 3 times a second. There's no media query that you can apply to get around this. There's no exemptions for your application for any reason at all, because it turns out there is nothing your application could be doing that means it's more important for it to flash than it is for people to not have seizures. All right, so just keep that in mind. You've got a lot of stuff going on in your app. All right, that is everything that I wanted to cover today. So if you wanted to have a look at the slides, you can grab them from svganimations.ez.codes, and then you can just jump in and have a look. If you inspect any of the animations in the browser, you should be able to see how they work. In the DevTools, you should be able to see how they work. And now please go forth and add animations to your application and make the web a more fun place.